I was hoping you'd be beyond proofs. I had another geometry student this week, and they had just gotten done with proofs and were on to parallel lines and transversals and angles and all the good stuff in geometry. So let's tackle this. Where do you want to begin?
Just at the top, I guess.
The top being what? There's a lot of...
Can we start at number 5?
Okay. So tell whether each is true or false. Is number 5 true or false?
True.
Okay. And what's the converse? How would you state the converse of this?
If two angles are congruent, then they are right angles.
Okay. Is that true or false?
That's false.
That's false, because they could be 30-degree angles. And they could still be congruent, but they wouldn't be right. Okay. If the statement or the converse is false, give a counter example, which I just did without reading it. Apologize. I would have had you do that otherwise, but I gave a counter example, which was if the converse is false because I could have two angles that were 30 degrees, which would make them congruent, but certainly not right. Okay, number 6.
Yes. Or, wait, no. That's false.
Okay, I agree. That's true. If x is greater than 7, then it has to be greater than 2. There's no way x could be greater than 7 without it being greater than 2. Now what's the converse say?
If x is greater than 2, then it's greater than 7.
Okay, is that true or false?
It's true.
No.
No, it's
Converse is false. Why? Give me a... If either one of them is false, then we have to prove it's false by giving a counterexample. What counterexample would prove that the converse was false?
If x was like 3.
Correct. Okay, how about number 7?
That's false.
Okay, what's the converse? Well, let's go ahead and give an example as to why that's false.
6.
Correct. Okay, what's the converse say?
If the number is if a number is divisible by 4, then it's divisible by 2.
Is that true or false?
True.
That is true. And that's worth knowing, actually, for math, that if a number is divisible by 4, then it is by definition divisible by 2. Okay, an animal is a penguin only if it is a bird. An animal is a penguin only if it is a bird. True or false?
False.
I believe it's true. I believe a penguin is a member of the bird family, although, gosh, I don't know how we're supposed to tell if this is true or false if we're not a professor of biology, because I was listening to NPR just the other day on radio, and they were talking about penguins were dinosaurs. They're remnants of dinosaurs. But I believe it's currently classified as a bird. So
Okay.
it would have to be a bird in order for it to be a penguin. In other words, it couldn't be a reptile and be a penguin. It's a penguin only if it's a bird.
Okay.
So that's true. And the converse, if it is a bird, then it is a penguin. True or false?
False.
And the counterexample?
Oh, like a pigeon.
Okay. Not sure why this is taught as part of math. I don't think it's math. It's logic. I guess sticking it in between algebra and geometry is the best place for it. Okay. Let's see what they have to say about biconditionals here. A statement combining a conditional and its converse is called a biconditional. So the conditional statement is if P then Q, the converse if Q then P. The biconditional is P if and only Q. Okay. For example, if an angle is 90 degrees, then it is a right angle. Well, the converse of that is if it's a right angle, it's 90 degrees, and they are both true, and so the biconditional would be true. If it's 90 degrees, if and only if it's a right angle, or it's a right angle if and only if it's 90 degrees. And their example also works fine, but I prefer math. I prefer geometry to days of the week, I think. I don't know. All right, so write the biconditional as two examples. Okay. So this should be pretty easy. Let's do number 9. Oh, speak of the devil. Swear I did not look at this. But number 9 is one that I just said. An angle is a right angle only if it's 90 degrees. Okay, so let's do 10.
Okay.
Right, each biconditional is two conditionals that are converses of each other. And what they're giving you in 10 is the biconditional statement. So write the two statements that came from.
Okay, so if DE equals FG, then line DE is congruent to line FG.
Okay? And the converse of that?
If if the line DE is congruent to line FG, then DE, the measure DE equals measure FG.
Good. Although I don't see the word measure in there, but in other words, I'm not sure I would add that.
Okay.
I think you can get away with just saying then DE equals FG.
Okay.
A little different than angles. Angles, you have to say measurement, the little m. In other words, if angle A is congruent to angle B, then the measurement of angle A is equal to the measurement of angle B. But with lines, I don't think you need that measurement. Okay, 11. Wow, hold on. All right, these are fairly straightforward, I think. In other words, You just eliminate the and only, right?
Yes.
And start in the middle.
All right.
So if you eliminate the and only and start in the middle, it starts out if B is on line AC and line CA, then B is on line AC. So that'd be one of them. And what would the other be?
Wait, how did you start out again? Sorry.
I started out in the middle just as a technique. Here, let me show you. At least use this once. In other words, I cross that out and I start right here. If B is on line AC and line CA, then go back to the end, then B is on AC. Cross out that if. Now, I guess, I don't know why I started in the middle. It's actually easier to start at the front. In other words, if I just add an if, hold on, to the beginning, then you would say, if B is on AC, then cross that middle part out and replace it with a then. B is on the other, and now the converse is easy. It's just replacing the if and the then. So that's probably a better way to memorize it. If I don't see this being a problem for you to memorize.
Yeah.
Mainly just a point about the definition of what biconditional means.
Okay.
Properties of algebra, we've covered these. So let's go through. Is one a problem or, yeah?
What?
In other words, these aren't example problems. This is one of your study problems, right? Yeah. Number one? Okay. So what property is that illustrating? If AB is equal to CD and BC is equal to BC, then AB plus BC equals CD plus BC.
Is that the addition property? No. Yeah, it is.
Let's look at the properties. Certainly not subtraction, multiplication, division, or substitution. Hold on. It's got to be the addition. Justify each statement with a property from algebra or a definition or a postulate from geometry. Okay. How about number two?
Mm-hmm. That be division property?
The division, is that what you said?
Yes.
Yep. Okay, number three.
Multiplication?
No, this is the substitution. In other words, in place of 1/2 the measurement of angle X, we're going to substitute the measurement of angle B. That's how we know that the measurement of A is equal to the measurement of B, is because they are both equal to 1/2 the measurement of angle X.
Okay.
Okay, so we are, doesn't this have another name also?
Transitive?
That's what I'm thinking. I think that's the transitive property, actually. So answers don't necessarily need to come from this list of 5 here.
What's the difference between those two?
Well, that's a good question. I'm not sure. I've always hated these this terminology. Not that that's an excuse, but let's see. What does it say about substitution? If x equal to 3 and x plus y equals 7, then 3 plus y equals 7. I'm not sure this is purely the substitution on 3. I'd be more likely to say that it's the transitive. Isn't that exactly what the transitive says? If A is equal to C and B is equal to C, then A is equal to B? Isn't that the transitive property?
Yeah.
And that's kind of what they're saying in number 3 here. Hold on a second. Let me close my office door here. Okay. I'll be glad to see a little bit of sunshine tomorrow. I'm getting a little tired of this rainy weather.
Yeah. It's really nice though.
Well, I suppose. We need the moisture. We always do. All right, number 4. If point B is in the interior of that triangle, then the measurement of XOB plus BOY equals the measurement of XOY. Now, it's hard to figure out what the heck they're talking about even, and for me, unless I draw a picture. So let's start by drawing a triangle that is XOY. And if point B is in the interior of that, there's a point B. Well, let's not even make it the bisector. Didn't say that, so let's not make it that. Let's put it right there. And that's point B. And then the measurement of XOB, that, plus the measurement of BOY, that, equals the measurement of XOY. Property is that?
It'd be substitution? No.
No, it's either the addition or what the angle addition, the angle segment. You know what I'm saying? In other words, what they're saying is angle 1 plus angle 2 equals angle 1 plus 2 equals the full angle XOY.
Okay.
What postulate is that? Isn't there a segment, angle segment addition? Something like that?
Is it postulate 10?
Do not know numbers. Perhaps, unfortunately, postulate 10, I don't have in a book anywhere. I've got it on your previous paper, and I don't have it handy. Do you have it handy?
No, I don't.
Okay. I don't think you need a postulate number ever. You only need to know what it means or what it says. And if my memory serves me right, this is the angle segment addition postulate. Just like a line segment. In other words, if I have a line and I want to break that up into A, B, C, then the line segment postulate says that AB plus BC equals AC. Well, this is the same thing only for angles, not lines.
Okay.
Okay, if 2 plus YZ equals 8, then YZ equals 6.
Would that be multiplication?
What do you have to do to solve that?
Or subtraction?
Subtraction. You have to subtract 2 from both sides.
Okay.
Okay. Let's go down here. Now they give us the other 3. That's not fair. Yeah, it was the right? I mean, shouldn't these 3 have been above those problems, not below them?
Wow.
Because clearly number 4 is the transitive, not number 4, number 3 is the transitive property. And the measurement of 1 is equal to 2, and if 2 is equal to 3, then 1 is equal to 3. That's exactly the way that problem 3 read. I suppose maybe on your, whatever book this came out of, this was all on the same page perhaps. I don't know. When I was scrolling down, we couldn't see this. So, did we miss any of the others? No, I don't think they had a symmetric property, and I don't think they had the reflexive property either, which is the funny one. That you have to say something is equal to itself. All right, number 6. Okay. Measurement of 1 is equal to the measurement of 3, then prove that DEG is equal to HEF. Oh, and this is just an example. Okay. All right, so let's look at number 6. These should be relatively easy because they give us one column from each row. Those are always easy. What is statement 1 for number 6?
KP equals ST, PR equals to me.
Okay. What is the reason for number 2?
Addition property of equality.
Yeah. Interesting. A little different application of the addition property, huh?
Yeah.
But nonetheless, what that says is that you can add 2 equations. You can add the left sides together and you can add the right sides together. So yeah, that's the addition property of algebra, I guess. Okay, and then KP plus PR is equal to KR. Why is that?
Substitution?
No, I think this is the segment addition property.
Oh.
Again, look at the lines over here. In other words, KP plus PR is equal to KR, right?
Right.
That is true because I have 2 line segments that the sum of those 2 line segments equals the sum of the entire line. And that is the segment property. At least I remember us using that as a reason. I'm not looking at a book right now. I'm looking at the theorems, but I think there's a segment line addition property and there's an angle segment addition property. And
okay.
That's what you're using for number 3, is the line segment addition property.
Okay.
And finally, number 4, what would the statement be?
So
all you really have to do to figure out what number 4 is go back and look at what we're trying to prove.
yeah, KR equals me.
Yeah, that's, in other words, as long as they're going to serve it up on a silver platter, you might as well take advantage of it. We know the very last statement has to be what we're trying to prove. Has to be KR equals SV based on substitution property.
Right.
This says the angle addition postulate. I'm looking at their example. That's what, instead of the segment angle addition property, it's the angle addition postulate. That's what makes DEG equal to 1 plus 2. And in our problem number 6, that is going to be the segment addition postulate instead of angle. So the reason for number 3 is the line segment addition postulate, or just not sure exactly what it would be, but you know what I'm talking about.
Yeah.
Okay. All right, we've got our given. Interesting. Hold on, they've screwed up here. Why are they doing this? Why is the given number 3? What is going on here? What are we supposed to do? Complete the following proofs by supplying the missing statements and reasons. Well, why are they out of order?
I think it.
Is it a typo, maybe?
Well, maybe they just want to like have us figure out something before we know it.
So they're saying the measurement of 1 plus the measurement of 2 is equal to 180 based on the angle addition postulate? I would base on that a linear pair. In other words, all linear pairs are equal to 180. I guess there's more than one possible response for a reason. I've always used linear pairs for that reason. I'm not even sure why it's the angle addition postulate. I guess it could be that also. In other words, angle 1 plus angle 2 equals the whole angle, which is 180. Still, that reason is a little disturbing to me. So the measurement for number 2, let's do it out of order. The measurement for 1 plus 2 equals the measurement of 3 plus 4. What reason is that?
Angle addition? No. Substitution?
I think that's the transitive. Right? In other words, the transitive says if A is equal to B and C is equal to B, then A is equal to C. Well, we have that. Excuse me, hold on. We have that is equal to A, or rather B. A is equal to B, and then C is equal to B also. Therefore, A is equal to C by the transitive property. So I'm pretty sure that one's the transitive. The given, we don't need to rewrite what they've already written. That's the given. So why is angle 2 equal to angle 3?
Because of the transit? No.
Seems to me they've left out a line.
Which one?
I don't know. This is a strange problem. It's rare that you see the number 3 being the given. But here's the line that I think they've left out, which is this one. Measurement of angle 1 plus the measurement of angle 2 equals the measurement of angle 2 plus the measurements of angle 3. Now hold on. Measurement of 1. Excuse me. That line right there.
Okay.
And that line, statement number 3, is true by substitution. In other words, is all I'm doing? Yeah, I didn't do it right. Yes, I did. In other words, in the given, 1 is equal to 4, right? So in place of 4, I'm going to put 1. And now I get 1 plus 2 equals 1 plus 3. And now I can subtract 1 from both sides, giving me what they're trying to prove based on subtraction.
Okay.
And I'm pretty sure that's what they wanted you to do with this problem. And the only thing is there should have been a given as the first one with the given. So this one really has 5 statements and reasons if you do a proper job of it.
Okay.
Imagine that was just a typo. All right, let's look at number 8. All right, the given is easy. Why is the measurement of angle 2 equal to the measurement of angle 2?
Because of, I remember this by reflexive.
Yeah. That's always the hardest one.
Yeah.
Because it doesn't seem like it should be a lot. It should be self-evident. Okay. So now the measurement of 1 plus angle 2 equals the measurement of AOI.
Mm-hmm.
Why? Oh, and 2 plus 3 equals EOU, which...
Angle addition property?
Yeah. Angle addition postulate, actually. Looking at this right there, that's the angle addition postulate in the previous problem. And then finally, 1 plus 2 equals the measurement of 2 plus 3.
Substitution?
Yeah. And finally, this one they want both the statement and the reason. What's the statement? That's pretty clever the way they do that because really you know what one of them is. In other words, the statement's always what you're trying to prove, right?
The measure of angle 1 equals the measure of angle 3.
Now, what's the reason for that?
Subtraction.
Yeah. Okay. Oh, proving theorems. Okay. So we're going to need the midpoint theorem on all of these. Yeah, it is called the segment addition postulate.
Okay.
That's what I was trying to figure out before. I thought it was a property, but it's a postulate. Okay. They give us an example. And finally, some questions. Number 5. All of 5 through 10 have to do with this figure on the right. So the measurements, let's see. M is the midpoint of NJ. Here, let me write some stuff on here just so we'll... A nice way to do geometry is to do things like this. That means M is the midpoint of NJ. In other words, it means NM is equal to MJ. State the definition, postulate, or theorem that justifies each statement. Measurement of angle 1 equals 1/2 the measurement of NJK. What is that based on?
Definition of midpoint?
No, it's based on the given.
Oh.
Well, maybe it's definition, angle bisector theorem is what that is. In other words, they tell us in the given that JL bisects NJK. And what that means when you apply the angle bisector theorem is that angle 1 equals angle 2.
Yeah.
And I guess that would mean, well, that's all it means, is that angle 1 equals angle 2, and that's not what they want to prove, though. They want to prove that angle 1 equals half of that. I guess you could say the angle bisector theorem along with division, right? Because if I say the measurement of angle 1 equals the measurement of angle 2 based on the angle bisector theorem, now if I divide, now it's not division, how do we end up with that? Measurement of 1 equals half the measurement of 2. Let's see, I know that the measurement of line 1 plus the measurement of line angle 2 is equal to the measurement of angle NJK based on the angle addition postulate. And if these two are equal, then I can substitute, and I can say the measurement of 1 plus the measurement of angle 2 equals M measurement of NJK. And now I have 2 measurements of angle 1. That's what I meant to write. Equals the measurement of angle NJK. Now divide both sides by 2, applying the division postulate, and you get the measurement of 1 equals 1/2 the measurement of angle NJK. Did you follow those steps? I think I left one out, actually. No, I didn't.
Okay.
This, first of all, this comes from the angle bisector theorem. That one. The second one comes from angle addition postulate. The third one comes from substitution. The fourth one comes from addition, and the fifth one comes from division. See how I got there? And I think that's what you, yeah, I think you need all 5 of those. If I was doing a 2-column proof. Now, they act like the answer should be one thing, right? They say state the definition, postulate, or theorem that justifies each statement. And yet it took me 5 things to justify that statement. So what do you figure they're looking for here? Do you have answers on these?
No, I do not.
Seems to me like we need a lot of definitions, postulates, and theorems to answer that. I needed 5 of them. In other words, that's statement 1. Actually, I needed 6. There's a given before this. In other words, that's really statement 2. Statement 1 would be the given. Statement 2 would be the angle bisector theorem. And then the rest of them. That was a 6-line, 2-column proof. What state the definition, postulate, or theorem that justifies each statement? Wow. Well, I wonder if their answer they want us to give is the angle bisector theorem. Let's see. That full theorem says that if that's a bisector, then the small angle is equal to half of the big angle. So I didn't need all 6 of those. I needed angle bisector theorem only. See what? In other words, the angle bisector theorem has 2 parts to it. If that's a bisector, then the measurement of this short angle, ABX, is equal to 1/2 the measurement of ABC, and that's exactly what number 5 says.
Okay.
So the answer to number 5 is the angle bisector theorem, and that's it.
Okay.
Okay? So apparently there is one answer for each of these. So 6 mj is equal to half of nj. Why is that true?
Because of the...
I think it's the midpoint.
Well,
in other words, m is the midpoint of nj. So we're going to call on the midpoint theorem. Let's go back and find the midpoint theorem because that's also part of that theorem. I think it's below. If we look at the midpoint theorem, I remember seeing it. Midpoint theorem. If m is the midpoint of AB, then AM equals 1/2 of AB. That's exactly what they're asking for here.
Okay.
Now, hold on. Where are we at? We're below this. Yeah, okay.
Yeah.
We were on number 6. And that is the midpoint theorem.
Okay.
Okay, number 7. 1 is equal to 2.
Wait, no. Congruent?
No, that's got to be the angle bisector theorem.
Oh.
In other words, if we go back to that angle bisector theorem, remember there were 2 parts to it?
Yeah.
No, that's not it. angle bisector theorem merely says that that angle is equal to half of the full angle and the bottom angle is equal to half of the full angle. It doesn't actually say that the top is equal to the bottom. I would still say that if I had to only give one answer, it's the angle bisector theorem for number 7.
Okay.
It has to be that. Now, maybe if you were doing a 2-column proof, you might have to get a little more elaborate. But if they're wanting one answer only, then that has to be the angle bisector. Number 8. NJK equals 1 plus 2. What's that going to be?
Addition property?
Angle segment, or angle addition segment, or whatever it said. Yeah. Okay, number 9. NM is congruent to MJ.
That would be the definition of congruency.
No, I think that's the midpoint theorem.
Oh, because M is, okay, never mind.
In other words, they give it that M is the midpoint of NJ, and by the congruency theorem, it means that segment is equal to that segment. Same way the angle bisector theorem meant that angle 1 was equal to angle 2. So perhaps it's a combination of the congruency theorem and the angle bisector, or the midpoint theorem. I'm not sure. It seems to me they're wanting only one thing for each of these. This is what I hate about proofs. And it would be a little helpful if they did give you answers. I would think, you know, at least every odd one or something, just so you can kind of check and make sure that you're doing it along the right track. NL plus LK equals NK.
Angle addition?
Not an angle.
Or, well, segmented?
Segment. Oops. Sure, as soon as I go point at it, it disappears on me. It's the segment addition property.
Postulate?
Well, let's see. I was just staring at it. Oh man. I get the segment, yes, the segment addition postulate. Okay, so that's 5 through 10. Oh, now back on our favorite thing, proofs. Now, this has nothing to do with that graph above, so it's the reason for number 1. Again, what's with the given in number 3?
I have no idea.
I know, we're just going to assume that, well, first of all, number 1 is given, right? In other words, there it is right there. That's the given. And PQ equals RS is also given.
That goes on line 3.
Maybe that's what goes there. PQ equals RS. In other words, yeah, I've never seen this before, but this makes a little bit of sense. In other words, they didn't put everything that was in the given in row 1. They just put 2 pieces of it. And the third piece they reserve for row 3. So what makes PM equal to 1/2 PQ and RN equal to 1/2 RS?
Would that be No.
Midpoint theorem. That is precisely what the midpoint theorem says. There's two parts to it. There's that's equal to half of that, and that's equal to half of that. That's really the only two parts they listed when they gave us the midpoint theorem. They didn't actually say that PM is equal to PQ as part of the theorem, which I found a little surprising.
Yeah.
Okay, and then PQ is equal to RS, which is part of the given. Therefore, half of PQ equals half of RS. What property is that?
Transitive?
No, I would say that's the multiplication.
Oh.
In other words, we're multiplying both sides by 1/2. You could also say the division. In other words, you could say you're dividing both sides by 2. So either one. And finally, what is going to have a reason of substitution property? In other words, remember the easy way to get the last statement? What are you trying to prove? Trying to prove PM equals RN, but why? In other words, we know that PM equals half of PQ. So therefore, wherever I see half of PQ, I can substitute PM. So it's the substitution property from steps 2 that's it. Well, in other words, step 2 had both of them. In other words, I'm substituting PM for half of PQ, and I'm substituting RN for half of RS. So steps 2 only. I don't know what that's for there. Sometimes I suppose it could be a combination of multiple steps, but it's statement 2. It's the only one I can see.
Okay.
All right, let's go to number 12. Please be beyond proofs by next week.
Tell me about it.
This is torture. No, I'm kidding. Probably more torture for you than it is me.
Yeah.
Trust me, geometry will get easier.
Okay.
It will definitely get easier. The moment you actually get into geometry, instead of all this theorems and proofs and stuff. So clearly, again, they have multiple givens. Well, the first one is still given. It's just not all of the given. And let's go ahead and fill in line 3 while we're at it. Line 3 has to be that, correct?
And the measure of angle RST equals the measure of the angle SRT.
Yeah, in other words, the rest of the given. I'm not quite sure why they chose to put this in 2 different statements, though I don't know why they couldn't have put it in one statement. I suppose they're trying to build on this logic. In other words, statement 2 comes directly from these 2 givens. Based on what? What theorem? What theorem?
What?
What theorem is statement 2 based on? This says that SV bisects angle RST.
Bisector.
Angle bisector theorem. In other words, that's exactly what the angle bisector theorem says, is that if a ray bisects an angle, then one angle is equal to 1/2 of the full angle. That's why we can say that angle 1 equals 1/2 of RST, is because of the angle bisector theorem. And the same thing with angle 2. Okay, and then we have another given. And now number 4, what would the reason that I can say number 4 given number 3? Why is number 4 true after looking at number 3?
Congruent?
No, what do we have to do to get number 4 from number 3? That's what you always want to ask yourself. Why is 4 true? What did we have to do to 3 in order to get 4? It's not congruent. In other words, you want to say that for all of these, but that's not really a factor in any of these theorems, the last few theorems that we've proved. It's not about congruence, it's about either multiplying, adding, subtracting, or dividing. This again is multiplication property. Right? In other words, all I'm doing is multiplying both sides by 1/2. Again, I could say the division property because I'm dividing both sides by 2. Okay, and now the last one has to be what we're trying to prove. And what's that based on?
The transitive?
No, substitution. In other words, if we go back to this statement, if the measurement of 1 is equal to 1/2 the measurement of RST, and now we're looking at 1/2 the measurement of RST, let's substitute the measurement of 1 for that. And likewise, the bottom half of that, instead of 1/2 the measurement of SRT, we're going to substitute the measurement of angle 2. So again, the last reason is substitution, which has been the last reason on a number of these.
Could it be transitive too?
I don't think so. The reason is the transitive says if A is equal to C and B is equal to C, then A is equal to B. Which basically says is that if one thing is equal to a second thing and a third thing is equal to that same second thing, then the first thing is equal to the third thing. That's the transitive property. Well, that's not what we're doing when we go to statement 5. We're substituting. We're substituting the measurement of angle 1 in place of 1/2 the measurement of RST because of statement 2. In other words, we have given statement 2, and now that allows us to substitute when I get to statement 4.
Okay.
Okay. All right. That's a good place to stop. I'll bet you still have more of these to do next week. Although, are you in honors geometry?
Yeah.
It's probably why you're still getting proofs, and my other student has gone on to the more common geometry. That's a lot easier. And trust me, once you get there, it'll still be a lot easier. Honors geometry will probably be a little harder than non-honors, but that explains why you're still doing 2-column proofs.
Okay.
And I don't know that that necessarily explains it, but that's the answer, I think. I still don't know why they would do that, but they do. In other words, why they would spend extra time on proofs.
Okay.
Janessa, I will talk to you next week, and I'll talk to your brother in just a second here.
Okay, bye.
I'm going to hang up and start another session for him. Bye-bye.